For this problem, I'd like you to predict the major and minor products of the reaction as well as provide a mechanism for how they're formed. So pause the video, take a few minutes to figure that out, and when you're ready, unpause the video. Okay, so hopefully you recognize aluminum trichloride as a Lewis acid. It's got an empty p orbital on the aluminum. We've seen that before in our aromatic electrophilic substitution reactions. The Lewis base is the lone pair on the nitrogen. So those are going to react to give us basically this molecule, which is very similar to the aziridiniamine we just saw. We basically converted this amine into a very strong electrophile with the addition of the Lewis acid. Now, the nucleophile, the aromatic ring, can come in and do a standard nucleophilic substitution reaction. But there are two places it can attack. It can attack this carbon or this carbon. And then the products would be, and I don't think I need to go over that whole mechanism, but we'll go ahead and number the carbons. 1, 2, 3, 4. So this would be 2, 3, nitrogen, carbon 4, and then of course, assuming after workup we get rid of the aluminum trichloride. The other possibility is it attacks carbon 3, and we get this. So two possible products. Which do you think is major or minor? Well, there's a couple things to consider here. Carbon 2 is certainly more sterically hindered. Okay. But the other thing we need to keep in mind is the electronic factor. There are some resonance structures of this molecule. So this is our ion, but just like a bromonium ion, we've got some resonance structures. We've got that one, and of course we also have it on the other side. So there's partial positive charge on both the carbons as well. Of course, this one is more stable, and therefore is going to have more positive charge and is therefore more electrophilic. Given that the aromatic ring by itself is not a great nucleophile, it's probably very important which carbon has more positive charge, and therefore I would expect the major product would be the one that puts the charge here, or at least in the transition it has the charge on the more substituted carbon, which is the one that gives us oops, and I forgot to draw carbon 1. Well, I forgot to draw carbon 4 on the other product. Sorry about that. So this would be our major product based on the electronic factor. Sterically, it would seem to be the other way around, but given that the benzene is not a very good nucleophile, we really need a strong electrophile, and so that's why I would think the charge and where it is plays a bigger role here.